So I didn't actually get last night when I signed off. After a minor hint on how to format my data better from Reddit, I was able to get it solved this morning. I may go over it. I didn't even go over 16 yet, but let's see how tonight goes. We have a gravity tractor beam. Oh, fun. Massive underground vaults. Oh, we're not going to do int code to generate our map today? Aw. Okay. Only one entrance is present among the marked the open passages. Assortment of keys and doors as uppercase letter. Okay. Access a large door and a key. Oh, okay. How many steps is the shortest path that collects all the keys? Okay, this obviously is a map solver. So, let us get some examples to go from. Okay. Another example. Another one. I like how we get lots of these ones where we get lots of examples are good. Shortest steps that collects all keys. Okay, so let's see, where was my last maze solver? Actually, it was a variation. Nope. Oh no, because last night we didn't actually solve a maze. 15 either. Alright, so we did here. And this is. So we will keep track character at each spot. We have an X and a Y. We have a cost to our point. And we have a hash that keys. Sim states. That'll work. Um. Oh, change to car. Okay. So. Find our next cell. Value. Y. Or say anything that's not on our map is a wall. Okay, so if it's not a wall, then we can, then this is a viable option. And and that adds a key. So char. Okay. Upper. Okay. So that will cover. Basically, if we don't have a key, we can't go through the. So if it's a wall, we can't go through. If we don't have a key, we can't go through. Does it say if we can move diagonally? Okay, well, we'll be able to find out. Because if so, we'll just need to add a few more things there. This is valid. In fact, we don't generate invalid nodes. So we're always true. And how do we find? Oh, we find the targets. Um, I really should wire up a static state, but well. Oop. Count. Cost, estimated cost is. Ooh, what is estimated cost? Plus. The number of keys we're missing. Okay, our key is Y and I just have that. That's no. I gotta build a map. Right. So we actually had something similar to this 2 nights ago, right? Oh, 2 nights ago was that. Yeah, probably not worth it. Okay, so that's going to be, nope. There we go. Let's char of char. X. Oh. Int. Map. And oh, I'm not going to start. Wait, what? Map node must be. Did it have to be convertible to that? Oh, because it's in because I explicitly provided the over. All right. Probably gonna crash, but hey, let's find out. Sequence contains no matching elements. Awesome. That's for line 19, which is starts. So, I must not have read in my map correct. Absolutely not. I have a single S. Heck did I do wrong? Well, the X and Y stuff is right. What's going on here? I feel like I did something dumb. Huh. I absolutely did. I was passed in input. Okay. Not what I was expecting. I is a string. Use this. Oh, wait, maybe not. All right. Well, actually, okay. That now should do it. Thought I could. No, I still. Wait, what? And where is the S coming from? Oh, okay. Instance of an object on line 25. Seem right? And am I losing a lot of time to this? Run scenario, part 1, line 40. Oh, whoops. Still line 43 of this one because I still didn't get a solution. Dump this out. I know I'm loading it correctly. Taking way too long. Darn it. Cloned that and didn't change nearly enough. Wait, oh. Because console writing is so. 886, 132, 136, 15198. But that was pretty slow. Nice! Rank 24, baby. Okay. Some of the keys are for doors and other vaults. Oh, interesting. So I have 4 robots. I have 4 moving at once. That's clever. Okay. Okay, so 1, area in the middle that looks like that. Huh. Clever. Okay. So I'm not going to bother trying to like get my code to modify itself. I'm just going to say, there's the make the corners. Let me just make sure I did it. Okay. Okay. Um, hmm. I'm better off just making this string. So that's still our map. Our X is now an array. Y. Effectively, I'm not going to try to track. I'm just going to say the first element in each array is a robot. Or sorry, the our elements, our robots are in arrays. R is 0. Length. R plus this. Okay. Shoot. Okay, so that's R. Okay. Let's see, I don't have a splice or anything. Array. Way. Well, not easy. Like, it'll be slow, a little bit slower than perfect, but hey, what? I almost made the same mistake I did last time. R equals X. X. Not sure if this is going to be slower or faster than the other one. I bet it's going to be. I think it's going to be slower, but each robot has to cover a much smaller space now. Alright. E. Just a string. Write it JavaScript style. Why is this not working? Oh, yeah, because tuple anymore. Alright. Oh, well, that works. That looks cleaner. Da da. Yeah, for some reason I'm just expecting this to be way too expensive to actually work. So 8. Yeah. So I got to do a better job of estimating. All right. Well, the algorithm's right. It's just really, really slow. Oh, actually, it was day 18. Whatever. I'll edit it later. Well, I'm gonna let that run on the second screen. Um, I've got a pretty expensive key calculation. I'm thinking calc that. Okay, that's still not running, or it's still running. Version of this. I want to get an idea for how fast I'm moving through the maze. Yeah, so my problem is I'm getting let's prioritize getting keys. No, but the problem is you're not allowed to overestimate, but you're allowed to underestimate. Sorry, you're not allowed to underestimate, but you're allowed to overestimate. Let's just make it a little bit more expensive. Not have the key you need. Ugh. Okay, well, let's put this over here. So one thought I'm having related to a better estimate is to do the sum of the minimum straight line distances to all the keys we don't have. Which is to say, let's see. So I'm currently getting num keys passed. I have to actually pass the list of keys. Ray. Okay, so this will be all the keys that we don't have yet. And then I need to take. Okay, okay, so I'm going to do this differently. Effectively, I'm going to build a dictionary that maps character or the keys where they live. Sorry about that. Yeah, this. I'm still at. I've only found 62. Okay. Okay. Okay, so that's the minimum cost to get all the other keys. Let's see. Shut that in case it's back to. Seems like rather large numbers because I did max. Well, it's definitely better. Still not zeroing in very fast. Just want to be able to get better progress. Still taking too long. Hmm. I mean, 2 arrays are not cheap, but they shouldn't be horrible either. I don't remember if it repeatedly calls that or not. I don't think it does. Okay, so that's not helping. I just need to improve my estimator, or I need to let it run overnight. um, have a parallel solver, don't I? Pass. I'd have to update a fair bit. Oof, I'm using a really large amount of memory. Again, that's because I'm not pruning my tree well enough. So all it really comes down to is I need a better estimator. Got a fair number of people found a better estimator. No, we do not. All right. So they are at least all split off in their own little areas. They can't cross. What if the answer involves simplifying the map? As in, if I can build a directed graph of all the stuff that is reachable and the distances between them all. So effectively what I would do is I would, from each possible starting node, from every node that is not a empty, that every node that is a starting spot or a door or a key, I build a directed graph between them, pathfind Pathfind from one to the other. Interesting. But I don't allow myself to go through um, a door. I don't allow myself to pass a key for those. So effectively, I pre-plan what all the paths are between things. Oh, holy shit! I think that's gonna be the answer. I think that's gonna be it. Okay, I've got my map. So all of my important points. Map. Where value that value that. Okay, so that's our important points. So now what I just have to do is get the distance between distance 1, 2, and I'm gonna start this. Okay. Okay, so we're going from an X. Oh, we have a cost, we have a map, we're not worrying about keys or other keys or any of those. Uh, okay, if it's that. Um, target. Turn. Map. Oh, target. Well, effectively, that'll be my success node. All right, otherwise we get a map. If it's not a dot, we continue. Because this handles the, so we don't abort when we get to our target. Is one and y 2 cost that. I for this one. Oh. Okay. X, Y. Oh, did it find the end? No, it can't possibly. New best estimated cost. Oh, no, it means it thinks it's closing in on something. Yeah. My target. Okay. Okay. Yeah, so it finally found the 24th. Now it's down to 23 keys. Wow, that's going to take forever. Guess we'll just let it run for the moment. Okay, so that gives the distance between our points. Actually, uh, fucked. I actually don't need the values. Okay. Well, in fact, oh yeah, because this will map in both ways, and it's only double the cost. Whatever. edges is now a dictionary to dictionary of distance. Okay. So now my map nodes need to take in that. Okay. Okay, so instead of going off of directions, I get value for R IR RE. Don't know how I'd be in that situation, but should we deal with it? Okay. Yeah, I can leave all this in. That we're in that cost plus edge dot value and pass edge long. Okay. Well, that doesn't look viable. Giant pile of memory got back. Well, that does seem to be closing in on an answer pretty quick. Well, let's see if the other one's got the right answer. 75, so new. 32 is right. 4 is right. 8 is right. 75 is not correct. Darn it. Maybe I should do this estimator differently. Well, that's still a pretty good estimator. Well, before I try to debug it too much. Okay, so it doesn't work. It didn't work for one of the examples, but it worked for the real thing. Yes. Okay, so this one worked out very much like I'd actually right at an hour. This one worked out very much like one of our maze finding ones from last year. Um, I seem to do pretty good at the maze finding ones. Having a reasonably working, already debugged solver really does help, and I really should fix my parallel solver. Um, but yeah, that's a lot of points. I was at 460 something last night. I'm at 622. So I went from off the leaderboard up to 83rd. I went 100 points off the leaderboard up to 83rd. Wow, that was a good, that evening they went well. All right, so let's since you've basically just heard me muttering myself for a while here. Last example doesn't All right, so let's start with tonight's, and then we'll jump back. So basically, a normal maze solver. Oh, and actually, I didn't really mention, but this real solver thing that I see in here is an A-star solver that, gosh, I wrote that for not last year's, 2 years ago. I want to say it was 2016, day 11. I think. Yeah, radioisotope thermoelectric generators. I didn't actually do 2016 except for a couple of selected problems that some of my coworkers thought were rather interesting. I didn't really start doing this in earnest until 2017. Um, but I went back to do this one, and this is the one where I had a coworker teach me that there are problems that don't look like graph problems that you, or sorry, that don't look like map finding problems that you can actually solve by pretending things are a map, by effectively treating some certain things as extra dimensions. Which is effectively how we solve this one, is we treat the number of keys you have as another dimension, so that we can differentiate between being at a given node. We can tell the difference between I'm here with 2 keys and I'm here with 4 keys, because you have different costs at different points there. So for part 1, we totally were fine, just doing a conventional, like I'm here, I needed to tweak my estimator a little bit. Actually, that's another thing to talk about. A star. Part of the reason why it works so well, better than like a breadth first search, is it also includes a function that estimates how much further it's got to go to its goal. Um, your estimator should always be, yes, you have to always estimate higher. You're not guaranteed to get a result. If I had to guess, that's why my last example didn't work. But for the first one, for part 1, I just used a relatively straightforward estimator of the number of keys remaining. So effectively, um, uh, if it still had 5 keys to go, then that was considered to be 5 more expensive than something that had the same distance but hadn't picked up a key. Again, this was deliberately designed to underestimate, because if you overestimate, you risk not finding your optimal answer. But yeah, it's not a very optimal thing, because your goal is to get as close as you can without going over, or as I refer to it, Price is Right rules. Um, because you don't want to overestimate, but underestimating is just fine. Um, so that worked well for this. We effectively started from our start point, and then we evaluate each of our possible moves in the cardinal directions. If we hit a wall, we stop. If we hit a door that we don't have a key to, we stop. And by stop, I mean these continues effectively. Oh, I guess I need to back up on that. This get adjacent method should return the next thing to look, or the next things to look at relative to a current node. So a node represents our full state at a given place. So our node, it contains where are we at, how much did it cost to get us here. We have the map, which is not actually going to change between things, the number of keys, which is not going to change between. But we also have the set of keys that we do currently own. Um, and so for a given state, our options are to move in one of the directions. If we would land on a door that we don't have a key to, that's not a valid place, so we don't need to consider it anymore. If we land on a place with a lowercase letter, that's a new key we would acquire, so we add it to our list of keys, and then we continue. Um, the idea here being the solver will gradually work its way down solution paths that are good. Now, part 2 got trickier because we now have let me scroll down to my thing here. We now have 4 robots running in the center. Now there's things in the cardinal directions here, basically keep each robot in its own box. So I mean, you could have treated them like removed part of the solution space from it, but that's not really necessary, because you can never walk through a wall to get over there. So it doesn't save you much since everything's already in a dictionary. But the interesting part is, because like here, you look at this robot. Okay, so it's got to go here and up and around, and oh wait, oh nope, now I can go through here. Like there's a lot of really long winding paths. Um, and it's got to, by only moving one step at a time, it takes a while. So what I decided to do was I built what I referred to as the edges. So I treated each, because there's only like there's no consequence to getting to one of these little dot nodes. You're just going to totally pass through it. The only nodes that matter are the ones that represent doors and the ones that represent keys. So what I did was I identified all of the all of the important parts in the graph, which is everything that's not an open space or a wall. So it would have identified the keys, it would have also identified the doors and the start points. And then what I did was I had it just run a simple A-star solver to navigate between those 2 points, and then I remembered that so that I know from this point I can get to here, or what's the cost to get to here, or what's the cost to get to here. Now, I only traverse open spaces, which means I don't have to worry about do I have the key or do I have the door things, or will I pick up a key while I'm on this route? It doesn't matter because the keys and doors themselves are part of my destination nodes. Or sorry, a part of the edges that I worry about. So this edges thing here will end up with, actually, let me just put a breakpoint here. Out. Just, it might work better to go. It's not where I want to breakpoint. Also not where I want it at. There we go. So if I look at this edges here, you'd see, so from whatever's at 1, 1, I can go to 33, 1 and 3, 4. If I go to 33, so these are all the places I can go without going through a door or a key or the start point. So from 1, 1, I can get to 33, 1 with cost 44 or 3, 4 with cost 5. And once I have that, I feed that then into, so my maze solver now is, instead of try to move each of the cardinal directions, we just look up, well, what are the outgoing edges from the node we're at, and we loop through the outgoing paths. So instead of, like for example, when I'm at 1, 1, instead of just moving in each of the cardinal directions and having to do that 44 times to get to this thing and getting lost in dead ends and everything else along the way, I can effectively jump straight here and just increment my cost by 44 instead of incrementing my cost by 1. This is actually a technique I have never thought to use with a maze solver, to try to effectively shortcut through a chunk of the maze, which is really cool. Anyway, so that's tonight. It's effectively maze solver with pre-detection or pre-calculation of paths between, of what the important points are and the paths between those important points, and then really only having to navigate between the important points for the actual solving. So 17, part 2. I didn't get solved last night. Let's see, 17. So part 2, last night, this was the thing with the scaffold and the map. Now I was able to generate this path, but what I wasn't able to do was simplify the path correctly. So one thing I took a look for some small hints on Reddit last night, or this morning, sorry. And I did find that, I think, do I have those in? Yep. So what I did was I generated, and again, this is link pad thing, so it's not going to look right here, but I have to try to ignore that. So I went through, and each direction plus number, so like this R8, I gave R8 a number, or a letter, sorry. So it was like X, Y, Z, W, X, W, X, Y, and Z, I think. Yeah. Maybe V? I don't remember. Anyway, doesn't matter. But I gave a letter to each just so that it simplified it, so I wasn't constantly trying to match these things. And then I ran a little bit of code that basically found all substrings, because as they're simplified like this, you can at most get 10 instructions, or sorry, 20 characters in a line, which is 10 instructions, which when simplified is 5. Now there's some combinations of 5 if they have if they have multiple double-digit ones, you wouldn't be able to do it, but that did actually turn out to be a problem. So what I did was I found all substrings of length 2 to length 5. There's only like 80 or so of them. And then I just looped through and I found, okay, pick one from A, pick one as A, pick one as B, pick one as C, do a and build regular expressions for each one of them, and then take my input and replace all my regular expressions. So like if ZYZ was the thing we were looking at, it would replace ZYZ with A and see what it got. Well, if I then got a string that only had A, B, and C in it, I had myself a solution. So from that, I just had a few, let's see, T2. So I just hard coded my, like, what my series of programs or main routine was, and then what my series of other routines was, and I told it I didn't want to watch it, and then I just ran my Intcode computer and let it do its thing, and then dumped out the data that I got, which was plug in. And then 16. Oh, got it. 16 was, this one was so, I was so close. So I was solving it. Um, the triangle stuff was what was, that's weird. 16. So I figured out that since we're only looking for some stuff at the very end, there's effectively this triangle of stuff that we actually fill in. Like I need to know in order to fill in the last slot. Oh wait a second. Actually, when we need to do the triangle thing, effectively I only need to know because all of the previous slots are going to be zeros, like they'll be multiplied by 0. So the this 4822 doesn't matter as when I only need to know from the fourth onward or from the fifth one onwards. First 4 digits don't matter. So yeah, I don't know why I was doing triangles, but anyway, the really important part though was to notice that this last one I needed 8, the last one I needed 5 plus 8, the last one I needed 1 plus 5 plus 8, and the one before it I needed 6 plus 1 plus 5 plus 8, so on. Effectively, for the last digit was just based on the last digit of the first one. The digit before that was based on the last 2 digits, and so on. I was looping through my target digits and then adding up all the digits that I needed. What I should have been doing was do the last one first. Well, the next one I could just add on this new digit. For the next one, I could just add on the new digit. For the next one, I can add on the new digit, and so on. So instead of this being an n squared loop, it becomes an n loop, and now I'm totally fine. Because to run a given phase, I only have to, it's not n squared by the number of, let's see, did I put the things in here? Yeah. So when I simplified it, it was 500,000 was the number of numbers to the end that I had to be calculating. So when I was doing an n squared, that was 2.5 billion operations 100 times. When I changed that to n squared, or just to n, now it was only 500,000 operations 100 times, or like 5 million or no, 50 million operations. 50 million operations we can do. Heck, a modern CPU does what, 5 billion a second? And I mean, cache misses will hurt us, and so will branch predict failures, but not by that much. So we're only trying to do 5 or 50 million operations, or 50 million iterations of that loop. I mean, that's sub-second. I think it was 300 milliseconds how long it took. So, yeah. So the trick on day 16 was realizing. I think there were 2 parts. It was realizing, one, you didn't have to calculate the first parts because only the last parts mattered. 2 was that all of that 0, 1, whatever stuff doesn't matter when you're only need the last bit or the last few numbers because they're all always going to be ones because of this repeat for the position we're in. Like these zeros are going to be used for all the numbers before where we start from, and then ones for all the numbers we care about. Because for our examples, we're always starting so far into to the end. We're almost at the end of the list of numbers. So yeah, so that was why we're able to very much simplify this. How we don't have that base pattern lookup stuff anymore. We're just adding numbers, and we know we don't have to go left any further. Thing is even if we had to go left further, because it's all going to be ones and zeros, you probably could have simmed the whole thing. That would have just meant instead of it being a primary loop of 500,000, it would have been a primary loop of 6.5 million, which is So, and instead of being roughly 50 million operations, it would have been roughly 600 million operations, which is still not that bad. 600 million operations is probably a second or two. Well, maybe 10 or 15. But still, it what it comes down to is the three tricks were realizing that this was just going to be zeros and ones, realizing that because it was zeros and ones, you could start a ways in. It wasn't triangle. I don't know why I was doing triangle. You really only needed to deal with the numbers itself. And then the third trick was realizing that once I had the last one, I could just add one more number and get the second to last one. And once I had that, I could add one more number, get the third to last one, and so on. So you stack all three tricks on top of each other, and you end up with a sub-second runtime. So, I'm guessing there was another trick or two that I didn't have for this one for tonight's, just because I should have like it still takes an actual amount of time to run. What are we, 10 seconds or so by now? There we go, 14 seconds to run. Yep. Still don't know why I did not collect quite the exact right value. So I don't know what I was doing, what I was doing wrong that got me this wrong, but got the last one right. I may have to debug that later. But it is nice to have, yeah, it's nice to pick up some leaderboard points. So last year, well, last year was 1 day short. Second. This year, I'm at 622. So 622 wouldn't have made last year's leaderboard. You figure if all the number-wise things hold, leaderboard will probably close around 800 for this year because we have one more day because day 6 had a bug in the puzzle. So we'll probably close around 800. So I'm actually not that far from likely locking in a spot on the leaderboard this year. Now, granted, we've only got 12. I can't do math. We've only got 7 more days. Oh, Christmas is next Wednesday. We've got 7 more days, and I'm probably 200 points away from what I would need to lock in a spot on the leaderboard for this year. I mean, it's doable. Heck, tonight I got. Tonight I got 157 points. I have, well, of course, this is an abnormally good one for me. So I had another one like that. Actually, see, that's my thing is I mean, I will have nights where I pick up stuff on the periphery, but I get most of my points from, well, not that one. I get most of my points from some really good performances. Actually, look at 18. I think I want to say that was the same in 18. But I have no. I had a lot more middling scores. I had a lot more 50s, and so it was a lot more consistent last year. Look at this: 50s, hundreds, 200s for most nights. I had one really bad one. It's 15 last year. I obviously didn't get that one solved. Oh, goblins and elves. Yeah, yeah. I must not have solved that one the night of. Well, I obviously didn't solve it the night of. I got the first part done, but I didn't get part 2. And same with 6. Oh, this was one that required you to do like sums of squares or something like that. Yeah, that was one I didn't figure out right away either. Yeah, this was the one I was real bad on because I couldn't get a solution for last night. But yeah, that feels actually does the leaderboard? I assume the leaderboard closed by now, right? No, it's not. Wow, the leaderboard is still not closed. An hour ago or 20 minutes ago, because I got in right about an hour. And even part one took a while. In part one, all you needed was a straightforward solver that just kept track of keys. In addition to you basically had to track your X and your Y and your the keys that you had found so far as part of your node state or a state or A star solve. Anyway, yeah, that went well. Now it's time for me to get some sleep. All right, I'll be back. I'll probably be back tomorrow night or tonight, or I guess we're past midnight, whatever. Anyway, good night.